In Lesson 9.2, you will find function values and determine the domain and range of a function. A function is a relationship that assigns exactly one output or y value for each input or x value. A function can be written either as an equation or in function notation. This right here is function notation. This is read as f of x equals 15x. I sometimes like to kid and call this function notation Fancy Nancy notation, because Fancy Nancy always uses a fancy way of saying things. Well, this is just a fancy way for saying y equals 15x. X is your input. You put in a value for x, you do the math, and what comes out is your y, or your output. In our first example, we're going to find function values. This really is just a plug and chug kind of problem. We are trying to find the function value f of n if f of x equals x minus 5. Basically, what we're doing here is we're taking 9 and we're going to plug it in for x. So f of 9 equals 9 minus 5. Well, 9 minus 5 is 4, so f of 9 is equal to 4. Basically, what that's saying is when we input 9, our output is 4. For our next example, we're going to find f of negative 3 if f of x equals 2x plus 1. So I'm going to plug in negative 3 for x. So f of negative 3 equals, remember 2x means 2 times x, so 2 times negative 3 plus 1. Well, 2 times negative 3 is negative 6 plus 1. Negative 6 plus 1 is negative 5. So f of negative 3 is equal to negative 5. You may want to pause the video and try the next two on your own. We're going to find f of 2 if f of x equals x minus 4. So we're going to say f of 2 equals 2 minus 4. So f of 2 equals 2 minus 4, which is negative 2. And now for the last one, we're going to plug in 6 for x. So we're going to find f of 6 if f of x equals 2x minus 8. So we're going to say f of 6 equals 2, remember this means multiply, so 2 times 6 minus 8. Now if we simplify that, f of 6 equals 2 times 6, which is 12, minus 8. So f of 6 equals 4. Now the domain of a function is the set of input values, or the x values. You would write the domain in these fancy brackets and separate them with commas. Range is the set of output values, or the y values, and the same thing goes for those. You would put them in these fancy brackets with commas between them. If a number shows up more than once in the domain or range, you just list it one time, even if it shows up more than once. So in example 3, it asks us to complete the function table for f of x equals x plus 5, then state the domain and range of the function. You've probably done tables like this before, where you put in something for x, do the math, and see what comes out. So it really is the same thing as you've done before, except for they're written in function notation. This f of x equals x plus 5 really is the same thing as y equals x plus 5. And we're going to put in something for x and see what comes out for y. So right in here is where we're going to show our work. So we're going to plug in -2 for x, -2 plus 5. -2 plus 5 is 3. Now we're going to plug in -1 for x, -1 plus 5. -1 plus 5 is 4. Plug in 0 for x. 0 plus 5 is 5. Now we're going to plug in 1 for x. 1 plus 5 is 6. So our domain is going to be our input. So -2, -1, 0, and 1. And our range is our output. That's going to be this column. It's going to be 3, 4, 5, and 6. The one way that I remember domain and range is I think alphabetically. Domain comes before range and x comes before y in the alphabet. So the domain is the x values and the range is the y values. You may want to pause the video and try the next one on your own. Our function is f of x equals 2x plus 3. So I'm going to plug in -1 for x. 2 times -1 plus 3. Well, 2 times -1 is -2, and -2 plus 3 is 1. Now I'm going to plug in 2 for x. 2 times 2 plus 3. 2 times 2 is 4, plus 3 is 7. Now I'm going to plug in 3. 2 times 3 is 6, plus 3 more is 9. Now I'm going to plug in 5. 2 times 5 plus 3, so 2 times 5 is 10, plus 3 is 13. So my domain, remember, is my input. That's my x values. So -1, 2, 3, and 5. Our range is the output, or our y values, 1, 7, 9, and 13. Now remember, functions can be written just as an equation as well. It doesn't have to be in function notation. This last example is just writing a function with 2 variables. It says an air conditioner repair service charges $60 for a service call plus $30 per hour for labor. Write a function to represent the charge C for a service call with H hours of labor. How much would the charge be if there are 3 hours of labor? Well, let's first write our equation. The charge is going to equal, it's $60 for a service call plus $30 per hour. So we're going to say $30 times the number of hours plus the $60 service call. Because it's going to cost $60 no matter what, plus $30 per hour. And that's going to equal the total charge. Now, how much would the charge be if there are 3 hours of labor? We're going to plug in 3 for the hours. So the charge is equal to 30 times 3 plus 60. 30 times 3 is 90, and 90 plus 60 is $150.